Hello everyone, how are you doing? Welcome back to your playlist TypeScript with tapaScript, and I hope you are enjoying this playlist throughout. Today we are going to discuss and learn about another important concept from TypeScript is called narrowing. If you are following along, you would have seen this example in one of the previous videos where we have a function called getPosition that takes an parameter called position which can be of type number or a string. Then in later point in time inside the function we are doing a check. We are checking that if type of position is string, then do some string operation, otherwise you print the position value as console.log. And we were also seeing the advantage of doing this is that we can call this get position with a number value, and also we can call the get position with a string value. So it means that we have made the get position function in such a way that it can accept a parameter of type number or string, and inside the function we are making sure that this particular function is never ever breaking because of the kind of parameter that we are passing. Think about a case if we didn't have this type of at all, then what would have happened? In that case, if we had invoked getPosition with a numeric value called 12, in that case position.split, it means 12 the number dot split, would have resulted in an error. We didn't want that error to happen, and that's the reason we tried to safeguard the definition of this function in such a way that we are making a type check ahead to making sure that the parameter value passed to this particular function is of a type string, then only perform a string operation, otherwise you do whatever you want to do. Here in this case we would have done a numeric computation. For example, we could have called something called toFixed like this, so that everything that we are doing over here is called narrowing. So what exactly is narrowing? In TypeScript, narrowing or type narrowing, it means reducing the type of a variable from a broader type to more specific and the precise type. In this case, in this particular line, the broader type was either a number or a string. What we have done with this type of thing is from this broader type, from number or string, we have narrowed it down to a string only using this particular check where we are saying type of position if it is string. If this is true, then this broader type, which was a union of number and string, is now narrowed it down to only string. And if this is not satisfied, then we will be sure that it is gonna be a number, because now in this method there is no way you can pass anything other than a number or string. Let me pass true. It is not even going to execute because we cannot pass a boolean to a function whose parameter type is defined to be a number or string. So if someone asks what's the definition of narrowing in TypeScript, you should say that in TypeScript the narrowing means reducing the type of a variable from a broader type to a more specific or a precise type. And this process usually takes place within a code block or a particular context. The example that we have seen just now, it was taking place inside a code block like a if else block. Okay, now there are multiple approaches of narrowing, and we are going to touch base all those approaches in these videos. Let us quickly write it over here, like what are the approaches we are trying it out today, so that at the end of it we can actually revisit and see like what each of those approaches meant to us. First, we will learn narrowing using the type guard with the type of operator. The same example what we have seen just now, we will take a few more examples to learn that much more deeper. After that, we will learn narrowing using equality operators. Then we are going to learn about narrowing using in operator. After that, we will see how we can take advantage of the instance of guard. Just like we have this type of guard, we also use the instance of guard to do narrowing in TypeScript. After that, we are going to learn about type predicates. So this is again a new concept, a new thought process that I'm going to teach you, that what type predicates are and how those are going to be useful in terms of type narrowing. And at the end, we will learn about discriminated unions, and then we will learn how in a situation where discriminated unions are used and we can leverage that to do type narrowing. So I hope that you are as excited as me to learn each of these different approaches and methodologies to get a great grip on type narrowing or the narrowing as a whole. So what is a type of operator? A type of operator in JavaScript is an operator that checks and gives the information of the type of values. The result that a type of operator produces is always a string that tells about what is the type of that particular variable's value. So it can, if it is a string value, it will return a string. If it is a number value, it will be returning a number, then big int, a boolean, a symbol, undefined, an object, or a function, right? Usually the type of guard or the type of operator can be used to distinguish between the primitive types. For interfaces and all, we'll be using something called instanceof, which we'll be covering in a bit. But right now, think in a way that for different primitive types, we'll be using typeof. So for example, we'll check it like type of value triple equals string to make sure that the type of this particular value is always a string, or it is a number or a big int in this way. Now, using this type of operator or the type of guard, we can actually narrow the type of variable to a particular type. In this case, if we have a if condition, inside if condition, we are having a check like this, we can narrow the type of this variable value to something called string. So let's take an example. Let's take a function, do something whose value can either be a string or a number. And just like the previous example we have seen, we can actually type guard using the type of operator, saying that if type of value is string, then I can do any string operation. So I can do console.log value dot else. I know if it is not a string, it has to be a number. So in that case, I can take an advantage of a number method, for example, to precision, and that's how I can execute this. Now this do something I can call with a string. I can also call the same with a number, right? So we understood that how using the type of operator we can create a type guard, and using the type guard we can narrow to a particular type or a specific type so that we can do that type of operation on the values or on the variables. Now let's take one more example so that we can get a little bit more deeper to this particular concept. Let's create one more function and let's give it a name called check and print. Again, it takes a value, and this time the value could be of type string, or let's say it could be of a type string array. Okay. Now we have taken a string and string array. Previously it was a string and number. Now here we can again perform narrowing using typeof, like if type of value equals to. Now how are you going to check the type of this array? So in JavaScript, if you do type of array, it is not going to tell you it's an array. It is going to tell you it's an object. Like this, if you do type of an array, it's going to return you an object. It's never going to tell you that it's an array. So it means if we have to put a type of guard on this particular value for an array, we have to check it like in this case, if it is an object, because for array is gonna be an object. And then here we can do anything with it. For example, we can do for const key of value, and here I can actually print each of this key. Else, what I can do like maybe simple console.log of value, because it's a string, or I can do value dot to locale uppercase, whatever, because it's gonna be string. I have already done my type checking for this one, the string array over here. So if it is not string array, TypeScript would automatically put it as string. Now to validate that, just mouse over on this value over here. You see what is coming as a parameter type? It's coming as a string. That's how in VS Code, you can check the kind of type inference happening for each of this code block, right? Based on the narrowing that we are performing. Over here, if I check for this value, I will see value is a string array. I won't see a string anymore. So see, that's the difference. All right. Now in this case, this will work great. Now let's say for some reason, this check and print may also accept a null. Now if you are pushing null to this, what might happen in certain cases? This particular value can be a null. Now if this value is null, there is always a possibility that things are going to fail over here. But wait, TypeScript is really not shouting. Why? Because in tsconfig.json file, the strict null checks is not enabled. So if I enable this one, now if I come back, I'm seeing an error. It says value is possibly null, right? Now in this situation, what are you going to do? You have to safeguard in such a way that this particular condition never executes when the value is null, right? So for that, you can take advantage of truthiness or the falseness of a value. So you can do something like value and then you can do this type of thing. With the conjunction of type of, at times you might have to also do the truthiness or the falseness check so that you don't fall into this kind of trap. Now, again over here, it is giving the same error, like the value can be possibly null. One way that you can definitely fix over here, again checking for if the value is true or false, and then you can do this. But the best way of doing this would be, you know that apart from null, it can be either a string array or it can be a string. Now the string array has been taken care over here. Now if you can be specific over here, you can narrow it more, saying that if type of value is string, you can safeguard from this error directly, because in this case you will go inside this only when the value is string, and if the value is string, there is no scope of null at all. You getting the point? So in this case, now you can call the function with an array like this it code sleep, a particular string, or even with null. Right, so I hope this type of check is quite clear to you and you understood everything over here. We have seen a couple of examples so that your understanding become much more stronger in terms of how typeof can help you alone to get to the narrowing, and at some point of time you also have to keep in mind about the null, undefined, and all this case, so you can bring in the truthiness and the falseness of the value along with typeof to get the narrowing in its perfect manner. All right, the first one is over. Now we are going to talk about the equality operator through which we can achieve narrowing. Let's see that. Just like typeof that we use as a type guard to do the narrowing, TypeScript can also use the switch checks or the equality checks for narrowing. Let's take an example to identify how we can do the equality checks to get into the narrowing. Let's take a function. We'll call it as do something again. And over here, let's take two parameters. One is like a, and it can be say of type string or number, and another parameter b, which also can be string. Another type could be array of string. And over here, we can do a lot of stuff. Now there could be situation where you can narrow down from this broader type. Here we are talking about three types. One is string, one is number, another is an array of string. Now from this broader type, you have a possibility of coming to a specific or the precise type through narrowing using the equality operator. Sometimes you can do this. How? Just notice here A is of type string. Here B is also of type string. It can happen. Now A can also be a number. A can also be an array of string. Completely different type. So if I am saying that A equals to B, in this particular case, I'll be always assured that whatever I am dealing with is gonna be string, right? Because A and B will be equal, the strictly equals, only if they are string. Because in this do something function, you can pass either a string, either a number, or an array of string. Now, if A is a string, B is a number, they are never gonna be equal. If A is a number, B is an array of string, they are never gonna be equal. So, only combination possible where they are equal is if A is a string and B is a string, correct? So, this could be one approach, and with this approach, I can do say some string operation. For example, A dot split, or I can do B dot to uppercase, something like that. And in the else case, now you can perform operation only which are related to either a number or an array of string. So if I do console.log of A and console.log of B, I just want you to see the type inference that happening. If I put my cursor over here, you see A is gonna be string, B is gonna be string. But if I put A here, is saying A can either be a string or number, and look at the B. B can either be a string or the string array. So the example we have just now seen is just a particular case to demonstrate you with the equality operator. There could be other cases where you can use the equality operator where it is triple equals or not double equals, which is like a not equal operator. And then based on that also you can do the narrowing from a broader type to a specific type. Now let us learn about type narrowing using the in operator. Why do you use in operator in JavaScript? So the in operator actually checks the existing of a property in the object. That's the objective of the in operator. Using that, we can actually do the narrowing of type and when object comes into picture. For example, let me create a type called say student, and here let me create a property called study, and the value of it can be simply an empty function. Okay. Similarly, let me create another type called employee, and here I will take something called work and let it be an empty function again. So now I have two types. One is called student, another is called employee. Actually, we can create the object of the instances of each of this student and employee if we want to. So it means that I can now have a function and we can call this function as activity. The name of the function is activity. And let's take, we have a variable called actor, and the actor can be either a student or an employee, and we can do certain things inside this. Now, one way that we can perform narrowing from the broader type of student and employee to a specific type, saying that if study in actor, in that case, return actor dot study, else return actor dot work. Correct? Now, if I put my mouse cursor on the actor over here, I would definitely see the type inferred as student. In this case, the type is inferred as EMP, means the employee. So you see here, I'm using the in operator now to narrow down the broader type from student and employee to a particular type. Here it is student, here it is employee. So using the in operator, you can also check the existence of the property in an object, and based on that existence, you can now narrow down to a particular type so that you can perform the action or the operation on that particular type only. Just like here we are saying study because study only belongs to student, and then work belongs to employee, because that's how it's gonna be resolved. Employee and work, student and the study. I hope you understood that. Now we learn about type narrowing using instance of operator. TypeScript can check if a value is an instance of another value. For example, I can say H is instance of human if and only if the prototype chain of H contains human.prototype. This is the definition, like how you find instance of. Now, if you're new to prototype chain, how these things work for object, I have a detailed video done for this. I provided that particular link into the description of this video as well. Please go ahead and check it out so that all this concept around prototype chain gets completely clear. Now there is an operator called instance of, just like type of, through which we can actually determine the instance of thing. So for example, I can say function check thing, let's say it takes a value which is of type string or JavaScript date value. Okay. Now here I can check if value instance of date. Okay, so date is an object, data object in JavaScript. If that is the case, then I can do console.log value dot. You see, the moment I do dot, I'm getting only the date related methods. So that means my VS Code already understood the value is gonna be a date only over here. So I can use something like toString, today string, or maybe get time. Otherwise, we have learned by now that if it is not date, it is gonna be string. So I can definitely do something like value dot to local lowercase, uppercase, whatever, some string operation on this one, right? So here using instance of, we are narrowing the broader type from date or string to the individual type, either date or a string. Now let's take little bit more complex example where we can create a class, we can create an instance of it and can do the instance of check on those values to get the narrowing done. All right, so let's create a class called student. We will have private name, private age, and let's also have another property called marks. Okay, so the student class is having name, age, and marks. Now we create a constructor. This dot name equals to name, this dot age equals to age, this dot marks equals to marks. And let's have a accessor method. We'll call it as get mark, which returns a number, and this is going to return this dot marks. One thing just want to kind of call it out. If you mouse over on this error, it will say duplicate identifier student, because student was also declared in a different file called C3 in operator dot ts. We have defined something called student. Again, we are defining student over here. It's only because if you don't position each of these TypeScript file as independent modules, all this thing gets added to a global module. That's why the name conflict happen. So there are multiple ways to fix this. The quickest way to fix that would be just add an export keyword in front of each of these things that are raising an alert or raising an error. When we get into the videos of tsconfig file, we will get into the deeper of this kind of error and see that how more gracefully and elegantly we can handle this. Okay, so for now I'm doing this export so that we can clearly say that treat this one as a module, and from this module we are exporting this class, something like that, so that we don't have this conflict anymore. Great, so we have the student class. Now I'm going to create a function called check marks. All right, And here I'm going to do value can be a student or a string, either of these two type. Now tell me, how using instance of operator we can narrow the type? Definitely we can do something like, if the value is instance of student, in that case I can definitely do console.log of value.getMarks, right? I can definitely do. Else I can tell something like console.log or console.error, whatever we can say, no marks available for student. I can do something like this, right? So now if check marks is getting called with an instance of a student, is gonna return me that particular student's marks. If it is called with a mere string, this is going to say no marks available for student, that particular string name. So if I call check marks with a student, for that let me create a student instance, let name it as Akash, a particular student's name, and say new student. It takes three things. One is the name, will pass as Akash. The Akash age is 23, and total marks, let's say Akash got 980 out of 1000. Now I can always do check marks and pass Akash, is gonna work. I can also do check marks a string tapaScript. Both works. So when Akash goes in, that means the value is a student. If I infer here, the value is student, so it is going to get me Akash marks. So coming here, I can do all sort of logic like, if value dot get marks greater than 800, student got first class. Between this to this range, got second class or third class or fail. Or if I don't find, I'm not able to finding it, particular student tapaScript, marks, I'm not able to find it, right? So this is how I can do narrowing using instance of operator, and you are seeing that again from the broader value, either student or string, it is narrowing into a specific one so that we can take action based on the type that actually we are using to narrow down the fact. Hope the type narrowing using instance of operator is also clear to you now. Now let's learn a new concept called type predicate. We also call them as type predicate functions. They have two special characteristics. All right. So one characteristic is they return a Boolean value. Let me write it down. They return a Boolean value. That's the first characteristic. And the second characteristic, they have a particular return type syntax where we use a keyword called is. Okay. They have a particular return type syntax where we use a keyword called is. Okay. Let's take an example as soon as possible so that we can understand. For example, let's have a function called is number. I'm not meaning this is as is over here. The is I mentioned over here is going to be in the return type. Okay, too many is. To make it short, we will very soon see whatever this is number returns, in that there will be this particular keyword is used. Okay, so is number, let's say the value can be any or unknown. I have not taught unknown, never, all these types yet. That's going to come in the future videos, but we have spoken about any. So let's take the value type as any. So there is no determined value. And here the return type can be a very specific type, saying that value, which is the parameter, is, this is the is operator I was talking about, should be a number or must be a number. Okay. And it has to return a Boolean value, right? So the Boolean value can be return type of value equals to number. So this is a predicate function because it satisfied both the condition. One condition was it returns a Boolean value. Second condition, it has a particular return type syntax where we use a keyword called is. And along with this, we are very, very particularly saying that the value is always gonna be a number. And now if we are using this method is number anywhere, the moment it returns a Boolean value, the moment it returns a satisfied criteria like this, it's gonna tell TypeScript that the value is a number. We are becoming very, very narrowed down with this type of narrowing. So this definitely provides a direct control on your narrowing. You can also say that this is a user defined guard, right? You are defining it very explicitly that value is gonna be a number always. It definitely increases the readability, because reading into this particular function itself, you can tell, seeing itself, that somebody has defined this function to always return a number. Is kind of, the value is always going to be a number based on whatever the test criteria, based on whatever the logic that you are writing here that logic must return a Boolean value. But this kind of approach is also having its own pitfall. For example, TypeScript will be very blind about this particular return statement over here. TypeScript is only bothered about that this particular return should return a Boolean. This is amazingly ridiculous. If I just make it a string, you see there is no error. What I'm saying that if the type of value is string, I'm returning value is number. So somebody by mistake with a typo or whatever can make this as a string instead of number. Still this particular function will execute without any error. But what is happening over here? We are equating the values type with string, no more a number, right? So this kind of error might happen when you are going to use type predicate. So you got to be careful. I will very soon take an example where I will explain like in what kind of situation you might want to go for type predicates and what kind of situation you can actually stay away. Most of the cases you can stay away, but there could be particular situation where you can actually go for it. We'll take an example for that. But before that, let's see like how type predicates can be used for narrowing down or for the type narrowing, right? So here we have is number. Now we can say function do something and it takes a value again and you don't know the type of the value. So in this situation, what you can do if is number value, now you can do some kind of number operation over here. You can say return value dot to fixed of 2, right? Else return null in all other cases. So in this case, you don't know what is the type of this value. It can be any type. So it's like true too broad. It is not even saying that it is a string or array of string or boolean, whatever it is. You don't know. You are checking here explicitly like if it is a number, then you perform a number operation on this value, and your this explicit check is based on this particular explicit return value where you are specifically saying that value is a number. So with type predicates as well, you can do the type narrowing. Now, before we move away, let us understand where exactly type predicates might be useful. So let's take a type called animal, and the animal can be either a cat or a dog, right? String types used in union create a new type called animal. We have seen this in the previous videos where we have discussed about different kind of types. Now I'm going to create an interface called pet, which is having an attribute called animal of type animal. All right. Now, as I have a pet interface, I can very well create a class called dog, which implements pet. Because dog can be a pet, correct? Right? And as it is implementing and it has a property, pet is having a property called animal, we have to define this property, provide a definition of it. So you can say, in this case, animal. Now this animal can be either a cat or dog. So in this case, animal is a dog. Okay. Now, along with this, we are also defining another public function called bark, animal bark, basically dog barks. And let's do a console.log of how dogs basically bark with bow wow sound, right? So now we have a class dog which implements. Now what we can do, I can create an instance of dog, right? One type of dog. So I can say const Doberman is one type of dog, is of type pet equals to new dog. Possible? What I'm doing, I'm creating an instance of dog, but making it as a type of this interface so that we can strictly adhere to everything that this particular interface alone provides. Had we done const Doberman colon dog equals to new dog, we would have created a dog instance directly from this class, but we are making it as an interface type so that we want to play around the abstraction that this particular interface provide to us. Now, can you do here Doberman dot bark? Can you do this? You cannot do this. Why? Because this bark method is not defined inside this particular interface. Somebody has not defined. Now think about it. Somebody has written this pet interface long back. You are creating dog now. Other people have created elephant, cat, mouse, everything. Now they have not bothered because they never had this bark method inside them. So they have never bothered to create something called bark inside this interface because bark only makes sense for dog. Bark doesn't make sense for cat. Cat will do something like maybe mew or something like that, right? Some different kind of sound. Now for that reason, this bark is not inside this pet and you are not able to call this one over here. Now, how can you still go ahead and execute this particular line? How can that happen? This is where your type predicate will come into picture. How? Now I can create a function, say pet is a dog, take a pet of type pet, And here in the return type, I can explicitly tell pet is dog, and what I can return? A boolean, return pet dot animal if it is dog. Return spelling mistake. So I have now written a type predicate function. The type predicate function explicitly saying that the pet that I am passing to this particular function must be a dog if this particular criteria matches. So if my TypeScript compiler now checking this pet is a dog based on the parameter passed to it and passing it, it will also allow me to execute this line because it will be sure that this pet passed to this particular function is always gonna be a dog because I'm explicitly returning this pet is dog, right? So now I can do, this is the beauty of TypeScript. I can do if pet is dog and I pass my Doberman over here, and I can very well take this line from here and I can put it here without any error. How amazing is this? So this is great. This is where your type predicate functions or the type predicate comes into picture, and it comes in very handy. Based on your type predicates, I have also kind of narrowed down this particular Doberman to be a dog, and I can call a dogs method on top of it, which otherwise I was not able to. So please use type predicates very wisely, because if I do cat here by mistake, this is still going to run. You see that TypeScript is never going to shout here, which it should have been, but TypeScript doesn't do. As it doesn't do, it means that blindly, based on any typo or anything else, it is blindly checking whether it is resolving to a boolean or not. If it is resolving to a boolean, then it is blindly certifying whatever you are giving as a predicate over here. So this kind of mistake, if you don't do, if you're very sure of it, you have a use case where you can really make use of your type predicates and the type predicate functions to achieve something amazing like this. I hope both type predicate functions and using the type predicate functions narrowing down to a particular type is clear to you right now. Let's move on to our last thing, where we will be doing narrowing using discriminated unions. We know about union operator already, right? Through union operator, we can define types which are of kind of variant types, right? And each of the type, there could be different type of properties altogether. For example, I can create a type called circle, and this circle can have a property called radius, which can be of type number, right? Similarly, I can have something called a type square. Here I can have something called side, which is also a number. Now though the type is exactly same, both are number, but radius is not same as side. Radius has its own definition for circle, side is having its own definition for square. Now I can create a new type using union operator out of these two called shape, and I can call them as circle union square. So that means the shape can now be a circle or a square. Now, if I have to create different instances, I can do like const s1 shape equals to say radius 1. I can create one object like that. Similarly, I'll create one more. I'll call it as s2, and this time I can say side, say 100 centimeters. This will also work because it can also be a square. So square can have a side, so it is allowed. But I cannot do something like this. I cannot say S3 shape age 23 because age is neither in square not in circle. So that won't work. Now let's take one function and we'll call this function as function get area. Okay. And here I will take shape as my parameter. Now if I have to calculate area of the shape, I cannot really calculate it directly because the shape can be a circle or a square. Now the formula for calculating an area of a circle is pi r square. For square, it is side square, right? The formula is different. So now I need something. I need some way to identify what is the type that I am dealing with over here, right? Now for that purpose, we need certain kind of properties, a common property to be available between square and circle that can clearly tell me that I am dealing with a circle or I am dealing with a square. That particular property is called a discriminant. Okay, that particular property is called discriminant because that property is now used to distinguish between different type of discriminated unions. I have two types of discriminated unions over here. One is circle, one is square. Now I can add one discriminant for circle and square both. I'll call that as kind or any other name of your preference, and I can call this one as circle, and same kind I will use over here, but I'll call this as square. So I have a discriminant now created. So using this discriminant, I will be able to get a definition properly for this get area. But this S1, S2 is shouting now because I have added the discriminant over here, but is not available in their definition. So I can quickly add that up. As I fix in this way, for S1, the kind is circle. For S2, the kind is square, because here I am using radius, here I am using side. Now coming to the definition of get area, I can now pretty well write it in a way using the discriminant, saying that if s dot kind, if it is a square, in this case I will return s dot side into s dot side, right? That's the formula. Else case is definitely gonna be a circle. In this case, I'm going to return math.pi into r square, radius square, s dot radius into s dot radius. Cool, na? Now I can call get area by passing s1, it will work. I can pass s2 as well, that also will work. So I can pass a circle, I can pass a square. For both, I'll be able to get the area. And even if I am just mousing over here, the type inference that I'm seeing over here is square, because I'm checking this, and the else case is gonna be a circle. I hope you understood the discriminated unions, what is called discriminated unions, and the narrowing of discriminated unions using a particular thing called discriminant. In our case, the kind property is the discriminant one. Now, I have done a string-based discriminated union over here, like string-based things we have done. Apart from string-based, you can also do number-based. That means you can take a particular property which is of type number and can do your logic, your basically narrowing logic based on that number. There is something called type-based discriminated union. I won't be teaching you that here, because to teach you, I have to teach you the concept of generics. When we cover generics, along with that, I'll be also touch base the type-based discriminated unions over there. You know, the only reason is I don't want to confuse you with too many things at once. So along with this, we have learned almost all type of ways through which you can achieve narrowing in TypeScript. There are few things that you will also see in terms of narrowing in future. For example, we have not discussed about a thing called never, right? So things like unknown, never, all this thing has to come in the future video, and as and when we discuss those, you will see that through them also we can actually achieve narrowing, right? But in the majority of the cases, see TypeScript code where you see the type check and want to fall into a specific type from the broader type, you will see these cases mostly. So we have covered type of, type guard, equality operators, in operator, instance of, type predicates, and the discriminated unions. I hope you enjoyed this video, and if so, please like this video and kindly share this video and about the channel to your friends, relatives, or others who would like to learn things from this channel. It would be a great help so that more people would come to know about it. And if you have not subscribed, kindly subscribe to this channel, because it motivates me to create much more greater content for you. Stay well, keep learning. I'll be back again with another video very soon.